In addition to the rip and insert bends features, SOLIDWORKS has a tool that automates the process of converting existing parts into sheet metal parts. The tool is called Convert to Sheet Metal. Here I have a solid part which I would like to convert to sheet metal. I want all of the faces to become flanges except for the cylindrical face and the back top face next to it. I've also created a sketch on the top of the part where I'd like to create a rip so the part is symmetrical when it's unfolded. This is the Convert to Sheet Metal icon. It can also be accessed through the Insert, Sheet Metal drop-down menu. When the Property Manager appears, the first selection window asks to select a fixed face as a starting point. The face you select will remain stationary for the flanges to be bent from. I'll select the bottom face. When I do, you will immediately see a preview. Next, I'll define the sheet thickness. Notice the side of the face the thickness is being applied to. I can use the reverse thickness checkbox to switch it from the inside or outside of the face. Notice that this part is basically being treated as a surface body. The Convert to Sheet Metal tool uses only single faces or surfaces to establish where the surfaces of the sheet metal flanges will end up. That's also why a surface body would act that same way as a solid body when using this Convert to Sheet Metal tool. Below the sheet thickness, I can set the default radius for bends in the part. The next selection box is for defining bends in the part. The easiest way to do this is start from the fixed face and work outwards. I'll select the 4 edges of the fixed face. While I do this, SOLIDWORKS will automatically show ripped edges of where the flanges will meet. In the graphics area, you will see flags representing the different rip and bend edges. You can edit the values of the radius or gap of specific edges throughout the part. The default gap distance is found just below the Rip Sketches box. Next, I need to add a bend on this top edge. When I do, the preview shows the flange extending all the way across the part. In this example, I actually want 2 flanges with the rip in the middle. To do this, I'll activate the Rip Sketches box and select the sketch I want to use for the rip. The preview updates to show the flange extending up to the sketch. I can now activate the Bend Edges box again and select the opposite edge. The preview updates and looks the way I want it. It is not necessary for every edge to be defined as a rip or a bend. The cylindrical face and the small top face will not be used in the sheet metal part. It will simply be left as open space on the sheet metal part. Before I click OK, I'll set the Auto Relief section at the bottom of the Property Manager. I'll set it to Ob Round and set the relief ratio to 0.5. Everything looks good, so I'll click OK. When I do, the solid part is converted to a sheet metal part that can be flattened. And at this point, I could continue to add more sheet metal features to it. Before concluding this lesson, I want to show you one more example of a part that started as a sheet metal part in another CAD system and imported into SOLIDWORKS. Notice SOLIDWORKS only sees it as a solid body with a single imported feature and not a sheet metal part. And if I bring up the Measure tool, you can see it has a thickness of 2 millimeters. I'll again use the Convert to Sheet Metal tool to add the sheet metal and flat pattern features. I'll select the bottom face of the part for the fixed face. Remember that the thickness is defined from this fixed face, so even though the imported part has a thickness of 2 millimeters, I can still define the default sheet thickness to a slightly different value. Since this part started as a sheet metal part in another program, it already has a bend radius applied where the flanges meet the base. In the Bend Edges window, I need to select the rounded faces instead of an actual edge like you saw in the first example. To save time, I can also use the Collect All Bends button to automatically select pre-existing bends in the part. The rip edges and sketches will appear blank since the part is already created with gaps between the resulting flanges. Changing the auto relief on the part will also not do anything since auto relief is already defined in the part. The part looks good, so I'll click OK, and the sheet metal and flat pattern features are added to the part. In my introduction to sheet metal design, I mentioned there were 2 approaches to designing in sheet metal. You can either design parts as sheet metal from scratch using sheet metal features as we've seen so far, or you can design parts as regular solids and later convert them into sheet metal parts. At this point, let's turn our attention to the second approach. Let's take a look at how we can convert the simple thin-walled box into a sheet metal part using the Rip feature. The main purpose of the Rip feature is to break corners apart so a part can be manufactured using sheet metal techniques. This will allow SOLIDWORKS to flatten the part and add bends where they are needed. You'll find the Rip feature icon on the sheet metal toolbar. Once the command is active, a selection window appears. If you hold your pointer over the selection window, SOLIDWORKS prompts you to select edges to rip. These must be linear edges. Later we'll see how sketches can also be used to define rips. For now, I'll select all 4 vertical edges. As I select the edges, notice a couple of arrows appear. These indicate what the resulting geometry will look like after this edge is ripped. In the case where 2 arrows appear, each side will be shortened, leaving a small gap between them. If you click on one of the arrows, the side shown by the arrow will be shortened, leaving a gap only on one side. I'll select different directions on a couple of these edges so you can see the results once the Rip feature is complete. You'll notice in the Property Manager there is a Change Direction button. This allows you to select an edge from the selection window and toggle through the different arrow directions, just like I did by clicking on the arrows themselves earlier. Since the rip feature will replace corners with gaps, you do have the option of controlling the size of the resulting gaps. At this point, I'll click OK to complete the rip feature. Notice the different appearance of these corners. Some are shortened only on one side, while others are shorter in both directions. This is the result of the direction arrows I selected earlier. Next, let's take a look at an example of using sketches to define rips. Here I have a thin-walled part. Notice it is currently not a sheet metal part and it cannot be unfolded because all edges are fused together. I could use the rip feature and break apart 3 of the 4 edges. However, I'd like to instead leave the edges intact and create a seam at the center of this face. To accomplish this, I'll create a sketch on the angled face. I'll sketch a line that goes from one midpoint to the other, completely crossing the entire face. This is all I need at this point, so I'll exit the sketch. Now I can use the rip feature, but rather than selecting edges, I'll select the sketch line. As before, I have to specify a gap distance. When I click OK, you can see the part is split at the sketch line and the corners remain intact. To complete the transition into a sheet metal part, I'll click Insert Bends, select a fixed face, click OK, and the sharp corners are replaced by bends. And the part can now be flattened. In the previous lesson, we saw how the rip feature is used to break apart solid corners and replace them with gaps. The next step in converting this part into sheet metal is to introduce bends to replace the sharp corners that remain. This is easily done using the Insert Bends icon from the sheet metal toolbar. This brings up the Insert Bends property manager. Portions of this interface should look familiar. Here at the bottom, you see a section called Rip Parameters. This is exactly the same as the rip command from the previous lesson. Since the rip and insert bends features are used together quite often, SOLIDWORKS has included the rip feature in the Insert Bends property manager. This allows you to accomplish both features at once instead of using the rip feature by itself. Let's take a look at the rest of these settings. A selection box at the top of the property manager prompts you to select a fixed face or edge. I'll select the bottom face and specify the default bend radius to be used in place of the sharp corners. I'll use the K-factor bend allowance type using the default 0.5 ratio. The auto relief section is the same as we've seen in several other sheet metal features. You can have SOLIDWORKS introduce rectangular, tier, or ob-round relief cuts as they are needed. Once I click OK, SOLIDWORKS notifies me that auto relief cuts were made. As you can see, the part now has bends in place of the sharp corners. The part is now converted from a regular solid into a sheet metal part that SOLIDWORKS can flatten. Because we took the approach of converting a non-sheet metal part into sheet metal, 3 new features were added to the feature manager tree. First is the sheet metal feature as the result of using the Insert Bends command. If you were to edit this feature, you would see it is exactly the same as the sheet metal feature we've seen in previous lessons. It contains the default bend radius, bend allowance, and auto relief settings. The second new feature is Flatten Bends. This feature contains information of each individual bend. If you were to edit these bends, you could change things like the bend radius used and the order in which the bend is applied. The third new feature is Process Bends. This is the feature that transforms the flat pattern into the finished part. Notice the feature manager tree now lists the flat pattern feature we've seen in regular parts that are designed as sheet metal parts from the beginning. Clicking the Flatten button unsuppresses this feature, and we can see the new flat pattern. There is also a new No Bends icon available on the sheet metal toolbar. When I click on this button, the tree rolls back to just under the sheet metal feature in the feature tree. This represents the part in its sharp corner or pre-sheet metal state. Now that this part has been converted into a sheet metal part, I can use any of the sheet metal features we've seen in previous lessons. For instance, I can add an edge flange. What I have now is a hybrid sheet metal part. It started as a converted non-sheet metal part, and now I've added a regular sheet metal feature. SOLIDWORKS lets you convert solid and surface bodies to sheet metal bodies using either the Convert to Sheet Metal feature or Insert Bends. Which one you use depends on the model you're working with. As a rule of thumb, if the model I want to convert to sheet metal doesn't look like a sheet metal part, then I use the Convert to Sheet Metal feature. If instead the model looks like sheet metal, for instance, if it's thin-walled or already has curved edges that look like bends, then I like to use the Insert Bends feature. In this case, I want to create a casing that fits perfectly around this solid body. While I'm not going to convert this solid body into a sheet metal part, I can still use the Convert to Sheet Metal feature and apply the thickness to the outside of the part instead. I'll launch the Convert to Sheet Metal feature, and in the Properties Manager, I'll first set the sheet metal parameters. I want the flat pattern to lie on the top plane, so I'll select the bottom face of the part as the fixed entity. I'll set the thickness to 1/16 and bend radius to 1/12. Since I want to create a casing for this solid body, I'll check the Reverse Thickness checkbox. I don't want to keep the body, so I'll leave this other option blank. Next, I'll select the bend edges. With the group box active, I'll select an edge that represents a bend of the part and work my way outwards. I'll repeat this process of the other sides. If you accidentally make a wrong selection, simply click the edge again in the graphics area. Before I click OK, let me quickly define the rest of the options. Under corner defaults, I'll set the rip type to open butt, rip width to 1/16, and overlap ratio to 1/2. I'll set the K factor of 1/2, and auto relief to tear, and 1/2. The part looks good, so I'll click OK, and I'm done. You can see the feature manager has the sheet metal features, and I can also flatten the part. Next, let's look at how to convert surface bodies into sheet metal features. If I try to convert this surface into a sheet metal body using the Convert to Sheet Metal tool, notice I have the option to set the parameters, but since this part has curved edges already, I can't select the edges to bend. In situations like this, you can use the Insert Bends feature instead. Let me exit the command and delete the sheet metal feature that was just created. Notice the Insert Bends feature is grayed out since I don't have a solid body. To quickly turn this surface into a solid, I'll go to the search bar and type thicken. I'll click the command, and the command manager appears. I'll select the surface to thicken the outside, and set the thickness to 1/16. I'll click OK, and now I have a solid body that I can convert to a sheet metal part. I'll click Insert Bends, select the fixed face, and set the bend radius to 1/8. I'll leave the rest of the options at the defaults and click OK to create the sheet metal part. This last body already looks like a sheet metal part, so I can also use the Insert Bends command to convert it to sheet metal. Before I do, notice I won't be able to create rips on this top face because it doesn't have any edges. To fix this, let me create a few sketch lines where I want the rips to be. I'll create the sketch on the top face and sketch the first line. I'll select the start point, the end point, and double-click to finish the sketch line without exiting the line tool. I'll create 3 more lines, and exit the sketch. Now I'll create the sheet metal part. I could use the rip feature to create the rips before I convert it to a sheet metal part, but I want to do this in a single step, so I'll simply click Insert Bends, and in the Bends Property Manager, I'll select the fixed face and set the bend radius to 1/8. Next, I'll select the edges to rip. With the edges to rip selection box active, I'll select all the edges I want to rip, set the rip gap to 1/16, click OK, and the part is done.